Assalamualaikum and hi everyone. Today we are going to study about gas absorption process in a packet tower column. For the cross-sectional area is 0.18C and at 293K and 101.32 kPa. For the inlet air contains 2.6 more percent acetone and for the outlet 0.5%. The gas flow is 13.65 kg mole per hour. For the pure water, inlet flow is 5.36 kg mole water per hour. For the film coefficient for the given flow in the tower are 3.78 multiple 10 power minus 2 kg mole per sm cube mole fraction and for the single mass coefficient 6.16 multiple 10 power minus 2 kg mole per sm cube mole fraction. And for the gradient for equilibrium line is 1.18C. To calculate all this question, firstly you need to draw the graph. Before that you need to draw diagram of packet column. For the this is example of the diagram of packet tower. For the packet tower contain two main stream, gas stream and liquid stream. For the gas stream will enter into the packet tower is V1 and outlet gas is V2 and inlet for the inlet L2 is the solvent, and for the exit solvent is L1. Okay, this is some of information to calculate. Surface content air surface content area 0.18 m square, temperature 293K, pressure 101.32 kPa. For the single mass coefficient in gas 3.78 multiple 10 power minus 2 kg mole per sm cube mole fraction. For the single mass coefficient in liquid kg 6.16 multiple 10 power minus 2 kg mole per sm cube mole fraction. For the system operating in dilute solution, so the liquid is the same with liquid out and also the liquid, which means L1 equal L2 equal L. Question will give equilibrium gradient, so that value is used to find equilibrium line. Take any value in graph and substitute in the equation. For the graph, this is example of the graph. Plot operating line, and if we want to plot, we must have two coordinates, which is point 1 and point 2 coordinate. For point 1 which x1 y1 and point 2 x2 y2. We don't, and so right now we don't know for the value of x1, so we need to find it. To find x1 we need the material balance, so So we must substitute all the value which have been given into the material balance and solve S1. Okay, this is for to calculate the material balance. After that, we got the answer S1 equals 0.006479. For the next step, we need to find the operating line. Okay, we need to find this line. If we want to find this line, we need to locate point 1, and right now we have as 2.2, so we can locate point 2. Okay, for the we have S1, Y1, so we can locate point 1, and we have S2.2, we can locate point 2. We have two coordinates to develop the operating line. We have to find slope. We have to use the equation for back absorption column. This to develop operating line. This is the value of point 1 and point 2, and this is how we find the slope. Since we know the value of for S1, Y1 from the material balance, so we can find the value of PM1, which equal to minus 1.60 by using the linear relation, which is ym x y equal ms plus c. So we got the answer 0.0364, and to verify the slope is accurate enough, we have to use the value for yi1 and si1 to be inserted back to the original equation for the packet absorption column, which is second trial. This is second trial for the example of the equation. We have to solve 1 minus ym and 1 minus sim, and these two equations you can get it from the appendix. y1 and s1 is already in the question, which is the material balance, and yi1 and si1 is from the previous value we get on the graph. So we got the answer from the second trial. Since P1 trial for the second trial and combine for the first trial, the slope is accurate enough. And for the y1 and s1 is already in the question, is the material balance, and yi1 and si1 is from the previous value we get on the graph. So we can solve both of the equation, which is 1 minus ym and get 0.909, and the other one is 1 minus sim and equal 0.9901, and then just substitute in the original pack absorption column, then you will get the value for the pack absorption column for the second trial, which is Pn1 equal minus 1.6. for the next step is to find the second slope of the graph, which is PM2 line. Since we have already have the value of PN1, which is equal 1.6, we can use the gradients to find the coordinate of PM2 line, which is we need to find the coordinate at x-axis using the same gradients. So we need to find PM2, need to find this point, so we need to calculate it first. Okay, so we can use the equation of y/mx plus c, and we got the answer is 0.005 for the this from for the y it will be 0 because and we want to substitute for the y, and y will be substitute for 0 because coordinate of y at x-axis is 0 and m is minus 1.6. So we want to find the value for x, and c is y-intercept for second slope, which is 0.05. Then we will get the value for x, and we have to find the coordinate for PM2 line, which is 0.003. And after that we just plot the graph, and we draw from the P from the P to this coordinate 0.003, and this will be our second slot. And then after that we can find the SI2 and YI2, where the intersection of the two slot and equilibrium curve is the value of SI2 and YI2. Okay, for the value, okay, this is how we calculate SI2 and YI2. These are on the graph, so we got the answer 0.003627. After we get the value of S for the SI2 equals 0.00175, and for the YI2 and 0.0021, and we calculate, and the answer 0.00367. After that we get the value. After that we got the value of SI2 and YI2. We can find the S2 star and Y2 star and Y1 star and S1 star based from the graph. Y2 star for the Y1 star. Yes. Firstly, we must identify this value because we want to solve for the question number C, where we have to use overall mass transfer coefficient on mass and liquid. Next, for the next one, we need to find SI minus SM, where we have to calculate this equation y minus yin, because we have to use to find the last equation, which is z which is a question. Is it for the last question, which z is the question A? Okay, this is for question A. Calculate our single mass coefficient. The B is to find the value of z. To calculate value of z, we using the formula we press y1 minus y2m. So v press is from the equation y1 and y2 is from the material balance single mass coefficient for the question, and so we want to determine z and y minus yim. So to solve y minus yim, we must look back at the solution we have done before and just substitute it back in the equation. And to make it easier, we can make z as the subject, so it is easier for us to make the unit cancellation. Okay, this is substitution. This is how we calculate for the VAV by using substitution method into the equation. For the VAV is actually the V average, which is V1 plus V2 per 2, and make sure the unit for volumetric flow rate and mass transfer coefficient is standardized based from the question. The unit for mass transfer coefficient is in unit hour, and volumetric flow rate of V1 and V2 is in second. So we have to standardize. We just divide by 3600 second, and then we 3600 second, and then substitute the equation, and you will get the value of z by using single mass transfer coefficient in gas phase, which is 1.946. For the next step, to calculate z for using single phase mass transfer coefficient in liquid, we have to find the value of Si minus Sm in the equation for Si minus Sm, which Si minus Hm we get the value of S1 minus we get the value for the S1 minus S2, and we can, after that we can get the value from the material balance and Si1 and Si2. For the Si2 we cannot get from the graph, and for the Si1 we get from the slope number 1, which intercept to the equilibrium curve, and it will be our SI1 and SI2 for the slope number 2, which intercept with equilibrium curve, and then substitute back into the equation, which is L average is actually the same value as ATLU. L1 equal L prime equal L average, so just substitute into this equation and we will get the value from a bit the same with single mass transfer coefficient in liquid, which is almost 2 meter. Okay, example for the slope. For the next one, we are going to continue to calculate the tower height using single mass coefficient. The question doesn't give us the clue of single mass coefficient to calculate Z, so we need to calculate the single mass coefficient using the equation. So we must make sure that we pick correct equation to calculate the pad absorption column. The equation to calculate single mass coefficient for the pad absorption column, where you need to calculate for 1 minus y star m, 1 minus y I m prime, and 1 minus s I m. For the y minus y I m and 1 minus s I m is actually we have calculated before we solve our question A and B, so we just use the last trial to calculate 1 minus y I m and 1 minus s I m, where for our m prime value is actually the value of the gradients of equilibrium slope, which is this question is 1.186. And for the field coefficient, we can get from the question, and then after that we can solve the single mass coefficient by rearrange the equation, and after we get single mass coefficient we substitute back into the equation. But before that we must complete to solve y minus y star m, and find the appendix, and to find y minus y must calculate it first. So this is an example how we calculate y minus y. By using this equation, where we must use the value y1, y2 and y1 star, y2 star, and again y1 and y2 we can get from the material balance, y1 star and y2 star. Y1 star you get from the graph is from the P1. This is y1 star. The direct line to the equilibrium line without going through the slope. So from the P1 and just drag the line to the equilibrium slope and go to left, we will get the value for y1 star and for y2 star. Y1 star and this y2 star. This y2 star. This from the point 2 we go to the line, and this is the value for y2 star, which is 0. For the y2 star the value is 0. Then after you solve the equation, after you solve the equation, we will substitute the value into the last equation, which to calculate z. And again, what we need to do is rearrange the equation and make z as the subject for easier to do the unit cancellation. We must calculate it before we will find z, which we look again is almost 2 meter. After we calculate, we got the answer for the VAV per S by using calculation VAV per S, y1 minus y2, and we got the answer for the Z is 1.934 m. So that's all for me. Sorry for if I I'm sorry of my mistake. I'm sorry if I have a mistake when I talk something. Thank you for watching my video.